Hello Gr12s and welcome to question number 4 of the November 2021 Physical Science Paper 2 exam. My name is Natasha Barton and I would like to thank you for joining me in this video. This question deals with reactions in organic chemistry. And before we go along and look at the problems, I would like to remind you of a few very useful acronyms that are going to help you in this section. Firstly, we have triple S or SSS, which stands for saturated to saturated is a substitution reaction. We have USA, unsaturated to saturated is an addition reaction. SU, saturated to unsaturated is elimination. And lastly, we have CEDS, concentrated is elimination, while dilute is substitution. These are really very useful acronyms which we will make use of in this video. I do suggest that you write them down, learn them off by heart, and use them in this section when you are studying and when you do write your final exam. So question number 4 says, compound P is used as a starting reactant in each of two reactions as shown in the flow diagram below. You can see the flow diagram provided. Then they say 1, 2, and 3 represent organic reactions. So whenever I am dealing with a problem like question number 4, I find it useful to always start off by analyzing the flow diagram, because I find that when I do so, it helps me to think, order my thoughts, and avoid confusion when I read the questions. It also allows me to answer the questions a lot faster. So try this method and see if it works for you. I will, however, be using it in this video. So if we look at compound P, we see that we have only been provided with a molecular formula. So we don't know the order in which these atoms are bonded. We also don't know the types of bonds that exist between the atoms. But compound P will be placed in the presence of dilute sodium hydroxide. This is a dilute base. Now if we go up to the acronyms, we see dilute substitution. So already we know that reaction number 1 is a substitution reaction, and we're going to write this down on the question paper. When the substitution reaction takes place, we see that the compound 2-methyl-butan-1-ol is a product. Immediately I'm going to go and draw the structural formula of this compound. As you can see, we have a chain that consists of 4 carbons. We have on the first carbon atom the hydroxyl group, which is the functional group of the alcohols. And then we have on the second carbon a methyl group. And this is 2-methyl-butan-1-ol. What happened during the substitution reaction is that the bromine atom was replaced by this hydroxyl group. We therefore can trace our way backwards and draw compound P. And we're going to draw it because, again, the structural formulae are very useful. So if you look at compound P, we now can see that in reaction number 1, the bromine atom was replaced by the hydroxyl group. So now we know how compound P looks, and that is going to help us with the other reactions. We look at reaction number 2. It says concentrated sodium hydroxide. If we go up to the acronyms, we see concentrated is elimination. So already we know that reaction number 2 is an elimination reaction, and I'm going to write that down on my question paper. What is being eliminated? It's going to be this bromine atom, right? In the end of this reaction, we're going to end up with a unsaturated hydrocarbon, a salt, and water. But compound Q is an organic compound. So let's go and draw out that reaction, or let's at least go and draw compound Q, the substance that is going to form when the bromine atom is removed or eliminated from compound P. If you compare compound P and the new substance I've drawn, compound Q, you can clearly see the bromine and a hydrogen atom from a neighboring carbon atom was removed, and we therefore have a double bond between the first and second carbon atom. The rest of the compound stays exactly the same. Now compound Q undergoes a reaction where we have it in the presence of HBr, hydrogen bromide. Since we are going from unsaturated to a different compound, we can see clearly from the acronyms that the only type of reaction that starts off with an unsaturated compound is USA. Unsaturated to saturated is addition. So we know that reaction number 3 is an addition reaction. What are we adding? HBr. And we can see that compound R that forms is the major product. So we need to use Markovnikov's rule, which basically says that the hydrogen atoms are going to go, or the hydrogen atom that is being added is going to go to the carbon atom that already has the most hydrogen atoms attached to it. So if we look at Q, we can see that the first carbon atom already has 2 hydrogen atoms attached to it. So therefore the hydrogen atom will go there, while the bromine atom will go onto the second carbon to form compound R. In the end, compound R looks like this. So we can go and fill in more gaps if we'd like. So you can go and fill in as many gaps as you'd like to. For example, reaction number 1 is a hydrolysis reaction. Reaction number 2 is dehydrohalogenation. And reaction number 3 is hydrohalogenation. All of this we write down on our question paper to help us to answer the questions that follow. Now that we have looked at the diagram, the flow diagram, and filled in all the gaps, let's look at question number 1.1.4. It says, name the type of reaction represented by reaction number 1. We already know this is a substitution reaction. So we write down the words substitution, and for that we're going to get 1 mark. If you'd like to, instead of substitution, you can write down the word hydrolysis, but always write down the version that you're most certain of. Question 4.1.2 says, is 2-methyl-butan-1-ol a primary, secondary, or tertiary alcohol? Give a reason for your answer. So you're going to get 1 mark for your statement and 1 mark for your reason. Fortunately, grade 12s, we have already drawn 2-methyl-butan-1-ol. So all that we need to do is go back to our sketch and analyze. We see that here is the hydroxyl group. It is attached to this carbon atom. In order to determine what type of compound this is, we see how many carbon atoms that carbon atom is attached to. Since it is only attached to 1 other carbon atom, we know that this compound is a primary alcohol. So we write down the word primary for 1 mark, and then we can give one of the following reasons. We can say that the carbon atom of the functional group is the terminal carbon atom. Or we can say the carbon atom bonded to the hydroxyl group, or OH, is bonded to only 1 other carbon atom. Or we can say the hydroxyl group is bonded to a carbon atom which is bonded to 2 hydrogen atoms. Or we can say the hydroxyl is bonded to a primary carbon atom. Any one of these would suffice for 1 mark. And that gives you your 2 marks for question 4.1.2. Question 4.1.3 says, write down the structural formula of compound P. Grade 12s, we've already analyzed and actually drawn compound P. So all that we now need to do is redraw it onto our answer sheet. So here is compound P with a bromine atom attached to the first carbon atom, we have a methyl group attached to the second carbon atom, and the longest chain consists of 4 carbon atoms. You're going to get 1 mark for your longest continuous chain, 1 mark for the bromine atom on the first carbon atom, 1 mark for the methyl group on the second carbon atom. If you added anything else onto the structural formula, you will be penalized. So it should look something like this. If you, of course, draw it the other way around, so the bromine atom over there and the methyl group over there, that is correct as well. Question number 4.1.4 says, name the type of reaction represented by 2. If we go up, we remember the type of reaction is an elimination reaction. If you would like to be specific, we call it a dehydrohalogenation reaction. And we can write that down for 1 mark. Question 4.1.5 asks, to which homologous series does compound Q belong? Again, we've already drawn out compound Q. If you look at the entire structure, it only consists of carbon and hydrogen atoms, so we know that this is one of the hydrocarbons. It contains in its structure a double bond, so we know that we are dealing with alkenes. Question 4.1.6 says, name the type of reaction represented by 3. Choose from addition, elimination, or substitution. Reaction 3, we have already concluded, is an addition reaction. So we write down the words addition for 1 mark. We now move on to question 4.1.7, which says, write down the IUPAC name of compound R. What is very nice is that we have already drawn compound R, so all that we need to do is name it using its structural formula. We start off by identifying the functional group of this compound. This compound only contains halogen atoms as a special type of atom or functional group, and therefore this is a hydrogen halide or a haloalkane. We know that the names of the haloalkanes end with -ane. Now we identify the longest continuous chain. This is the longest continuous chain with 4 carbons, so we are dealing with butane. Then we need to number the compound so that the substituents obtain the lowest number possible. So we therefore will number this compound that we have drawn from the left-hand side. We see that both the bromine atom and the methyl group fall onto carbon number 2. Since B comes before M, we need to name the bromine first, stating where we can find it. So it will be 2-bromo. The methyl group is also on carbon number 2. We place hyphens between letters and numbers, so it is 2-bromo-methyl butane, and this is going to get you 2 marks. You will get 1 mark for butane, and you're going to get the other mark for naming and giving the positions of the substituents. Of course, everything else needs to be correct. For example, the hyphen between numbers and letters. Question number 4.2 was a problem that many learners struggled with when they wrote this paper, so please do pay attention, but also try it yourself to see if you're able to solve this problem. They say 1,2-dibromopropane can be prepared from but-2-ene by a 3-step process as shown in the flow diagram below. What is unfortunate about this flow diagram is that they do not tell you or give you any clues about what happens during the steps. For example, they don't tell you the types of reactants added on, or the catalyst used, or any of the reaction conditions. Also, we don't know what compound A or compound B is. But that means that we need to see what is the possible relationship between but-2-ene and 1,2-dibromopropane. So how about we start off by drawing out the structural formulae of these compounds, because we know that the structural formulae give us a better understanding of what is going on. When we look at these compounds, we see that but2-ene is unsaturated. So the only type of reaction that begins with an unsaturated compound is USA. Unsaturated to saturated is addition. So we know that we're limited in grade 12, and step 1 therefore has to be an addition reaction. Already we have a bit more information than we started off with. Now if we compare the first compound, but2-ene, with the very last one, we notice firstly that the last compound, 1,2-dibromopropane, contains bromine atoms. So at some point, halogenation had to take place. We had to add bromine somewhere in these steps. Bromine had to be added, okay? But secondly, we notice that the first compound, but2-ene, contains 4 carbons in its longest continuous chain and only 4 carbons in its entire structure. But if we're looking at the very last compound, we see it only contains 3 carbon atoms. The only type of reaction that allows us to go from a longer chain to a shorter chain is cracking. So we know that somewhere in this reaction, cracking had to definitely take place. So now we can try to analyze what's going on. We need to try to see where we can crack the compound, where we can perhaps add bromine. But I would just like to point out that cracking is normally a process that starts off with alkanes. And that is another clue. So based on that, we need an alkane. If we would like to crack the compound, we're going to need an alkane. So how about we start off by taking but2-ene and we go and we add hydrogen to this compound. If we do so, we will find compound A. Now, if we take a look at question 4.2.1, it says, using condensed structural formulae, write down the balanced equation for step 1. Indicate the reaction conditions on the arrow. So we might as well go and try to write out step number 1 using what they say we should at question 4.2.1. Normally, I find that learners struggle to write out condensed structural formulae. So let's start off by using structural formulae. We'll then cross that out and draw condensed structural formulae. So right at the top, we have the structural formulae. As you can see, we have the alkene that is gaining hydrogen atoms. It's gaining or being reacted with hydrogen. In this reaction, we're going to need a catalyst. Specifically, we use platinum, nickel, or palladium. You can choose one of the 3. In the end, we end up with an alkane. Specifically, we have butane. Now, what we do is we go from the structural formulae to the condensed structural formulae as follows. The first carbon atom has 2 hydrogen atoms attached to it, so we write down CH2. Normally, we do show the double and triple bonds in these condensed structural formulae, and we leave out the single bonds, so we draw the double bond. We then have a CH, which we draw as CH. Then there is a CH2, here's the CH2, and lastly we have a CH3, which we write down as CH3. For this part, you're already going to get 1 mark, so I'm happy if you at least attempted it and drew out this compound, because we do know this compound for sure. Then we have the hydrogen, H2, you're going to get 1 mark for that. The catalyst that we are using is platinum, but again, you can use nickel or palladium. And if we look at the compound, the product that forms, we start off with CH3, then there is CH2, then another CH2, And lastly, we have CH3. You're going to get 1 mark for your product. And this is going to get you your 4 marks for question 4.2.1. Now that we've done question 4.2.1, we can continue with the question, and we see that 4.2.2 says write down the type of reaction in step 2. So now we go up. We know that compound A is going to be butane. As mentioned, we need to end up with a compound that only contains 3 carbon atoms. So now that we have the alkane, we can go and put it through a process called cracking. We can break up the butane so that we end up with propene. Because once we have propene over here as compound B, we can add to it Br2 in order to form 1,2-dibromopropane. So we're going to now write down 4.2.2. The answer is cracking. And for writing this down, we're going to obtain 1 mark. Something that I forgot to mention when we were busy with 4.2.1 is when you're done drawing your, condensed structural formulae from the structural formulae, please draw a line through it, because you do not want the marker to accidentally mark your structural formulae instead of the condensed structural formulae. So please, once again, I can't emphasize this enough, cancel out your workings so that the marker knows what to mark. Now question 4.2.3 says write down the IUPAC name of compound B. As mentioned, we're going to place butane through a cracking process. When it is cracked, so I'm going to go back to these formulae that we drew out. When this compound is cracked, we need to form propene. So what is going to happen is it will be cracked at this point. Of course, when it is cracked there, one of the hydrogen atoms here is going to bond to that part to form methane. And a double bond is going to form at this point. So we're going to end up with propene. Compound B is therefore propene. Now, although it is obvious that on propene, or if we're looking at propene, the double bond will always fall onto the first carbon, you're welcome to write down the name prop-1-ene or 1-propene, and you will also obtain your marks. This is 2 marks just for writing down propene. So if we go up to our rough work that is above the condensed structural formulae, we're going to take away this hydrogen atom as well as this section that we said would fall away or will be broken off. And here we have propene, right? So now what is going to happen is step 3 is going to take place where we're going to add bromine, right? At question 4.2.4, they say, using condensed structural formulae, write down a balance equation for step 3. Again, I suggest that you start off by drawing structural formulae and then go on to draw the condensed structural formulae. But please always take note of the time that you have available. Don't spend too much time on a question like this. So over here, we start off with propene. With its double bond, it's going to react with bromine in order to form 1,2-dibromopropene. When we take the structural formulae, we have CH3, then we have CH, double bond, okay? We are allowed to show the double bond, then we have CH2. You're going to obtain 1 mark for this. It's going to react with bromine. You're going to get your 2nd mark for writing out Br2. And lastly, this is going to form CH3. Then we have a CH. You can write out CHBr, or you can show the bromine attached to the carbon. Lastly, we have CH2. You can write CH2Br, or you can show the bromine directly attached to the carbon atom, and that is going to be your 3rd mark. So in the end, we did end up with the correct compound, At minimum, if you struggle with a question like this, at least go and draw out the condensed structural formulae of this compound and that compound so you can get a few of the marks. In the end, question number 4 is out of 21 marks, and this concludes the section on organic chemistry. In the next question, question number 5, we're going to be looking at rate and extent of reaction. Hope that you'll join me there.